Hi ladies, this is lesson 5.4. It's about parallelograms. We've talked about parallelograms back in chapter 1 if you remember, but today we're going to look at some special properties that they hold. So to begin, we're going to just start by defining parallelograms. So a parallelogram is a quadrilateral whose opposite sides are parallel. And if you were to draw a picture of this with your markings on your diagram, you would draw parallel lines and then another set of parallel lines. So if you think about a parallelogram, we know some special parallelograms we've talked about in chapter 1. And the first one is a rhombus. And it's a parallelogram with 4 congruent sides. So here's your parallelogram. And something special about a rhombus is that all 4 of these sides are congruent. The next one is a rectangle. And it's a parallelogram with 4 congruent angles. So they'll each be 90 degrees. So if, again, this is your parallelogram. Your special rectangle parallelogram has 4 congruent angles. And then the next one is a square. And it's a parallelogram with 4 congruent sides and 4 congruent angles. So again, here's your parallelogram. Four congruent sides and 4 congruent angles, which if all angles are congruent, they are all going to be 90 degrees. All right, so before we talk about parallelograms specifically, we have to remember some properties of parallel lines. So you'll see this diagram on your note sheet, but remember that corresponding angles are congruent. So an example of corresponding angles would be 8 and W, for example, or it could be beam 6. There are a ton of examples of corresponding angles in this diagram. So Z and 1, D and 2, 7 and 8. So you could go through the whole diagram and then list all the examples of corresponding angles, but those are just a few. So I'm just going to write down on here angle 1 and angle Z. That is one example of corresponding angles. Now the next example we have are alternate interior angles. And alternate interior angles are also congruent. This is with parallel lines. So alternate interior angles, Z and A would be an example. W and D would be another example. B and Y is an example. Or X and C is another example. So alternate interior angles are congruent. And I'm just going to write on here angle A and angle Z. But you can see all of these pairs up here. All right, and then the last one, alternate exterior angles. Alternate exterior angles are also congruent with parallel lines. So let's look at our alternate exterior angles. We've got 8 and 2. That's an example. Or 1 and 7. So they're on alternate sides of the transversal and outside of your parallel lines. Another example is 3 and 5. Or lastly, 4 and 6. So any of those are examples of alternate exterior angles. So I'm going to write down on here 8 and 2. That's just one example, but you can see, again, all the pairs up here. All right, so now looking at some characteristics of parallelograms. If you look at a parallelogram, we'll draw a visual, but opposite angles of a parallelogram are congruent. So if you look at these properties of parallel lines, you see a parallelogram in here. So here's our parallelogram. And we'll just call it ABCD. Here's our parallelogram. Our opposite sides of our parallelogram, which in this case is A and C, those are congruent. If we look at this diagram, let's look at angle A to start with, and we're going to work our way over to C. But angle A and angle Z, those are alternate interior angles. Looking at the orange line as the transversal. But now if we shift and we look at Z, and we look at the two orange lines as parallel lines, and the blue line becomes the transversal, then Z and C are corresponding angles, which makes them congruent. So Z and C are corresponding angles. A and Z are alternate interior angles. So A and C, therefore, are congruent. So opposite angles are congruent. So in our parallelogram, I'm just going to keep marking it every time. But in our parallelogram, here are our opposite angles. Those two are congruent, and these two are congruent. Now let's look at consecutive angles. And we'll go back to our diagram. But now focusing on consecutive angles, that would be like B and C, or C and D, A and W, or sorry, D and A, or A and B. Those are angles that are next to each other. They're consecutive angles. So what can we figure about consecutive angles of a parallelogram? Well, we know that opposite angles are congruent, and we'll just leave these markings here. Opposite angles are congruent. And we know that, so Z is also congruent to X. So those four red angles, those are all congruent. But what do we know about D and W? Those are alternate interior angles, so they're congruent. W and B, those are congruent. And B and Y, those two angles are congruent. So now if we look at these angles, they all form a line. So the green angles and the red angles all form a line. So D and Z are supplementary. That means D is supplementary with anything else that's congruent to Z. So D and A are supplementary, A and B are supplementary, B and C are supplementary, and C and D are supplementary. So we can conclude then that consecutive angles of a parallelogram are supplementary. So if you think of your visual, here's your parallelogram. Here's one set of consecutive angles. Those two consecutive angles are supplementary. All right, now we can look at opposite sides, and so far what we know about parallelograms and dealing with sides, we haven't really looked at this too much. But we have a little bit when we are studying properties of parallel lines. And with parallel lines, you know that if two lines are parallel, then any distance between those two lines, well, actually we worked with perpendicular distances, but this is going to be the same as this distance, for example. So with parallelograms, what we know about opposite sides is that they are congruent. So again, here's your parallelogram. And we have opposite sides congruent. And then lastly, the diagonals of a parallelogram bisect each other. So here's your parallelogram. Here are your diagonals. And those two diagonals bisect each other. All right, so let's look at this flowchart proof. So again, we're just walking through the steps and saying how we know each piece of what gets us to our final conclusion. So we have this parallelogram. We know it's a parallelogram, and we know that SA is a diagonal. So we want to show that SOA and AKS are congruent. So first of all, we know that it's a parallelogram. So therefore, and as we walk through this, I'm going to mark my diagram, and I encourage you to do the same thing. But SO is parallel to KA. So SO is parallel to KA. We know that because that's what a parallelogram, opposite sides are parallel. And then OA is parallel to SK. And that's also the definition of a parallelogram. This right here means parallel. So parallelogram. All right, then next we know that angle 3 is congruent to angle 4. And we know that because those are alternate interior angles. Similarly, we know that angle 1 is going to be congruent to angle 2 because of alternate interior angles. And then SA, so we're trying to prove the two triangles are congruent. So we know that SA is congruent to SA because it's the same segment. Now, if this flowchart was not already started for you, you could say that, KA is congruent to SO. You could say that SK is congruent to OA because opposite sides of the parallelogram are congruent. But we went with the angles. So we were given a diagonal, and so we went to prove that the angles 3 and 4 and 1 and 2 are congruent. So now SOA is congruent to what? So SOA, this triangle right here, do it in a different color, but this triangle starting at S, so S is angle 3, so we want to start with angle that's congruent to angle 3, which is A. So SOA is congruent to A, K, S. And that's because, oops, angle side angle. All right, so that's our flowchart group. And if you look at a couple of the homework problems that involve flowchart group, you actually use this as a beginning of part of the proofs, but you don't have any of those assigned as homework. But if you want to practice with that flowchart, you can do that. If the perimeter, so this is the last extra example, if the perimeter of the quadrilateral equals 52 centimeters, what's the value of x? Well, start with what you know about the sides. You're looking for perimeter, so you're dealing with the sides, and you know in a parallelogram, opposite sides are congruent. We also know opposite angles are congruent, but we don't really care about that for this problem because it's asking about perimeter. So we know that x plus 2, there are two sides of that measure, and there are two sides of the measure, 2x minus 3. In total, the perimeter is 52 centimeters. So to solve this, we need to do a little bit of algebra. So we're going to distribute on that too. So 2x plus 4 plus 4x minus 6 equals 52. And then we can combine our like terms. So we get 6x minus 2 equals 52. Add 2 to both sides, 6x equals 54. And then lastly, solve for x. And don't forget your units. So in this example, x equals 9 centimeters. And then the last example, given this as a parallelogram, solve for x. In this example, x deals with angles. So in a parallelogram, we know opposite angles are going to be congruent. We also know that these two angles are supplementary, consecutive angles are supplementary. And we also know that it's quadrilateral, so all four of those angles are going to add up to 360 degrees. So let's just start first with opposite angles are congruent. So we know that 2x is going to equal x plus 10. Therefore, if you subtract x from both sides, x equals 10. So if x equals 10, just as a double check, angle A would equal 20 degrees, and angle C would equal 20 degrees. So let's just double check to make sure that this matches up. So 20 plus 110, that does not equal 180. So this cannot be true. So right away, you know that there's not a solution for this because opposite angles have to be congruent in a parallelogram. Consecutive angles have to be supplementary in a parallelogram, which in this case, if opposite angles are congruent, then consecutive angles are not supplementary. And then thirdly, you know that they have to all add up to 360 degrees. And right now, they only add up to 260 degrees, which that's not what a quadrilateral adds up to. So in this example, there is no solution. So you could also start with looking to see whether or not, set the 2x in one time equal to 180. And if you did that, you got 2x plus 110 equals 180. So subtract the 110 for both sides. So x has to equal 10. X also has to equal 35. Alright, so we're going to, no solution. Because if x equals 35, then this angle is 45, and this angle is 70. Those are not congruent. And then you could do the same thing with 360 degrees. But again, here, you know that there's no solution. So please jot down any questions you have. Your homework is on your note sheet. And please come in and ask questions as needed. Thanks.